Good morning, everyone. Today, we're now at the module 6, which is ang title ani is Conservation of Momentum and Energy in Collision. Conservation of Momentum. So here we have duha ka picture. There's this person pushing a huge rock. Clearly, di gid niya ma-overcome na siya because it's too massive. The force needed is quite high. Then the second image is ang collision sa duha ka sakyanan. So we're gonna talk about this type of na mga physical phenomenon. I think you'll have fun with this one. Well, not fun na sulayan ninyo magbangga ang duha ka sakyanan. Okay, let's start. First is ang momentum, or here it's called linear momentum, denoted by a symbol P, capital P. Okay. So, as you can see, bold siya na P. It's a vector quantity. It's a vector quantity, so it's just mass times the velocity. So, clearly, makita nato na ang pagka-vector niya gikan sa ining velocity because mass is a scalar quantity. Mass times velocity, so it sounds and looks simple enough. So, if recall nimo ang Newton's second law of acceleration, which is the force is equal to the mass times acceleration. So, gamay na lang kulang if we divide this by if we divide this by time t, you get force. So expression of force is equal to mass times acceleration, and acceleration, if you remember, is the rate of change sa imong velocity with respect to time. So this one is clearly this expression here. So it's dmv over dt, the derivative of mass velocity over with respect to time. So we can change this into P. So you have force is just the differential function of the momentum with respect to time. So this is a re-expression of Newton's second law. So the force is now in terms of momentum. Impulse. So impulse is denoted by the symbol J. It's just the change of momentum from initial to some final. So that is impulse. So from Newton's second law, force kaganina na dp over dt gives us a function of the differential dp as the force times dt. Okay? And dp is equal to the sum of force dt. And if you take the integral of that one, which is essentially trying to measure from starting momentum to final momentum, it's equal to the integral of the sum of force dt. Okay. So you have J here, which is the change in momentum, can also be expressed as the change in momentum is equal to the force delta t. Okay, if we go back here, see? Okay, it's a re-expression naman siya sa delta p. Okay. See? Okay. Now, conservation of momentum sa collision. So you have here mass 1 ug mass 2, and they are moving at a velocity v1 and v2, and they are going towards each other. So this is the first scenario. Then you have the second scenario sa pag-collide. Obviously, di sila pass through each other, but bounce off each other. Okay. The x here simply denotes like it's in a Cartesian coordinate system. So one-dimensional naman siya. So it's just, we can ignore this one. It's just x. So these are the same particle. So what do you do? What equation will you use? Look at this. So you have the initial condition. Kanisha dire. So you have m1 v1 plus m2 v2. This one. Can I erase this? Gubat na lagi. Yeah. Okay, so yeah. So m1 v1 refers to this one, and m2 v2 refers to this. Okay, is equal to the after event. So it's equal to m1 v1 prime plus m2 v2 prime. So this is momentum p1 plus p2 is equal to p1 prime plus p2. This is the expression that describes this phenomenon. Okay. So, going back again to this condition, kaya mag-collide-collide naman natay mga interactions, the internal or external na mga forces involved. So, you have the force internal is just the force I on J. So, kani siya basically class is like these are particles inside a body. So this could be anything that you want, but inside the body, say for example in this some form of body, is that may ila pod interaction with each other. Now, if you look at the expression here, ang forces is simply the dp over dt, if you recall. But since duha ni siya, so we call this one as the differential of the sum of the body I interacting with body on J, so over dt. And this one is equal to 0. Why is that? So we're trying to remove the contribution sa imuhang internal na reactions here. So dp dt is equal to the sum of the force, which is the force internal plus force external. Okay, since ang imuhang internal we have set here na ang interaction is they would simply cancel out to 0, so this becomes 0, but ang contribution sa momentum will be the force external. Like for example, this particle here, this is outside of that body interacting with this larger na body. Okay, so internal na mga interactions are ignored basically. If the net external force is 0, outside force is 0, then we get the dp over dt equal to 0. Okay, internal nimo 0 and external nimo 0 po. So the change in momentum is equal to 0, which suggests that the momentum is constant. Okay, the mv is the same, which means that the total momentum is again conserved. The first collision, I think you've learned about this high school, is an elastic collision. So as the word elastic, pag mo igo, mo bounce off lang siya. So you have before collision, duha ka mass m1 and m2 going towards each other. Then after this one is, after sa pag-collide nila, they would move apart. Okay, for this particular na collision kaning elastic, conserve ang imong momentum. m1 v1 plus m2 v2 is equal to m1 v1 prime plus m2 v2 prime. So obviously here the masses are set as the same, so meaning ang mga speeds nila or the velocities would change. The velocities will change here, pero they will maintain a certain proportion of the total momentum from the initial. Okay, the next one is conserve ang iyang energy. Conserve energy, so meaning here they're all moving, so the energy present lang is ang kinetics. So the kinetic energy of m1 is given by this one, and m2 is given by this two. Okay, and what about it? And of course, ang after collision, you have 1/2 mv1 squared, it's this one, and the other one is the v2 squared. So we can simplify this. So initial mga 1/2s ma-cancel out because they're all present, and you are left with this expression. So you have the expression for the conservation of momentum and expression for the conservation of energy. So that's how ma-identify nimo kung not how to identify. Basta elastic collision, conserve ang both momentum and energy. So going further, so let's rewrite the expression. So from the conservation of momentum, we can group ang pareho na mass, so we transpose it on the other side, so you get negative v1 prime, then factor out ang imong m1. Similarly sa imong m2 v2 prime, i-transpose po nato ni siya on this side, so this becomes a negative v2 and factoring out m2. Similarly sa imong conservation of energy, you group again ang imong mga m1 v1, so pag kuha na niya mahimo siya og negative, So basically, ang mahitabo siya is m1 v1 squared minus v1 prime squared. Then the other one is equal to m2 v2 squared prime minus m2 v2, factoring out the m2, you get v2 squared. Okay, so this one now, if we apply algebra here na functions, so this becomes v1 minus v1 prime times v1 plus v1 prime. Okay, kung imo siyang multiply with each other, you will arrive to this function here. Similarly, this one, it can be broken into two, inicia of inicia. Okay, if you multiply that one, it would result to this function here. Now, what do? We then substitute the equations to get an expression of the final velocity. So basically, ini siya ng mga terms, mga final velocities. Okay, let's go ahead. All right, I went too far. Yeah. So, from the conservation of momentum expression, we can rewrite this by crossing this one here at the bottom, and this is equal to 1. Okay, same naman sila na proportions basically. And from the conservation of energy, we have this function m1 v1 minus v1 prime and so on. So if we put down ang imuhang v2 prime, i-cross nato sa ubos, you get this expression. Okay, so why is that? Because we need something initial na form para ma-substitute nato ang value niya. So this one is equal to 1, so hence 1 rayon siya. So 1 times this one is the same as this expression here. So that means we have simplified it into v1 plus v1 prime is equal to v2 prime plus v2. Okay, 1 naman siya. Okay. So we recall the expression for the change in momentum. So we have m1 v1 plus m2 v2 is equal to m1 v1 prime plus m2 v2 prime. So substituting the expression earlier nakuha nato, this one, okay, this one, and rewriting that one, you get an expression for v2 prime is equal to this function here. What do we do with that one? So v2 prime is we put this back into this expression here. So inicia. So hence amo ni siya kataas. So as is ni siyang kaning duha dire. But here you have m1 v1 prime plus m2 instead of v2 prime, you have this expression here. Then i-distribute din mo ha. Distribute mo siya. So you get this and this and this function here. So what do you do next is that, of course, we group like terms. So we can group ang mga v1 primes here. So that is m1 plus m2. Correct. The other one is m1 v1. Then you have your m2 v1 transpose ni mo dire. So it becomes a negative. And this one, negative m2 v2 transpose ni mo dire, it becomes a positive m2 v2. Since duha na sila kabuo, you can just add them as 2m2 v2. Okay? So, rewriting an expression for v1 prime, inicia i-cross ni mo paubos. So that means this becomes m divided by m1 plus m2. So it's this term here. Then this one, divide ni mo by m1 plus m2 and you get this term here. So this is the expression for v1 prime in terms of the masses and the initial velocities. Next one is imuhang v2 prime. So we use again this expression kanina, which is derived earlier, v2 prime, and this v1 prime here. So what do we do? So we know v2 prime is given by this, and we can substitute ang v1 prime which we solved earlier. So mataas agad siya. So v1 minus v1 minus ato sa gimove diri sa pikas na side v2, and we focus on the v1 prime, which is m1, this whole term here. Okay. Oh wait, naisayop. Sorry. Anong duha man siya kabo? Dapat wala ni. My apologies. Let me correct that one. So wala na siya. Okay. It's fine. Relax lang, guys. Okay. Is it fine? Let me check. Let me just inspect this. Yeah. So dapat wala na siya. Okay, so ano po diri? So, what do we do next? Then we factor out ang v1 ni Moha. Okay. This whole term here, by the way, is this one. Okay. We factor out ang v1, so you get a 1 here. And of course, v1, factor out ni Moha. Then, for this expression, so this is the expression here. Then here, factor out ni mo ang v2. So you have v2 factored out. So you have this term, or these two terms here. Okay. What's next? Ang imong buhaton now is ang pagsum na dayon sa mga masses. So you have m1 plus m1, that becomes 2m1, and m2 minus m2 is of course mag-cancel out. So hence you have 2m1 here times v1. Next is this one. Ang imuhang 2m2 minus m1 plus m2, kay imo man siyang gi-multiply basically, o not multiply, imo siya gi-minusan og ang parameter na m1 plus m2 over m1 plus m2. Okay, so that you can replace that one. Okay, once sa gapon is here. So what happens is that this becomes negative m1, this becomes negative m2. So ang 2m2 maminusan og m2 is becomes m2 lang. Then minus m1. So man siya ang expression sa imuhang v2 prime. Okay. Maybe I should correct it here. Wait lang guys. I should correct gamay. Erase this one. Okay. Just to make it more beautiful. Okay. Okay. So moving on, you have here a ball with mass 2m is moving in the positive x-axis. Sorry, positive x-axis. So we have 2m moving in the positive x-axis. So let's say this one is the positive x. Okay, and it hits a second ball that is initially at rest. Sa mga na siya v2 equal to 0. And after collision, the both balls move in the same axis along the positive x-axis. So padulong sila tanan dito, with the second ball moving at a speed of 5 meter per second. So dili sila the same silang direction, pero naguna ang isa. Okay, naguna ang isa. I think that's it. Okay. And the question is, find the final speed of the first na bolt. So the question is this one. Pila na siya. Okay, let's go. So, uh, after collision, ang nahitabo is that they move at different na speed. They're not moving as joint together. So, what is it? Is it elastic or inelastic? So, it's an elastic na type na collision. So, we go back to the equation sa momentum. So M1 V1 plus M2 V2 is equal to M1 V1 prime plus M2 V2 prime. So, ang pangutana is like pila daw ang speed sa mass 1. So, rewriting that expression, so we transpose kani siya to the other side, hence may mo siya negative M2 V2, then we divide it by M1 para we get an expression for the V1 prime. Since ang imong V2 is at rest, ang second mass at rest, so this becomes 0. Okay? Ang imuhang 2m, naa siya speed na 10 meter per second. Then, this one is of course moving in the positive direction. Okay, positive x. And kani siya, ang second na mass nimo after collision is still moving in the positive direction, pero it's moving in this way, so you have mas lower 5 meter per second. Okay, the negative comes from pag-transpose nato sa kani siya. So then divided by mass 1. Ang mass 1 nimo is 2m, so it's 10 meter per second times 2 ni mo that's 20 or 20, depende kung uno mo accent yan ha. So 20 na siya. Then you minus it by 5 and you divided by 2. So you get 7.5 meter per second. And this one is still going to the positive x direction. Same naman sila o orientation. Lahi lang sila og speed. So, final speed nila. So, consider natin siya na elastic collision. Let's go. Sa inelastic collision, it's like this. Nakay duha ka mass, M1, M2. Pag collide nila, ang final speed nila is just 1. Meaning, dungan sila or nagtapot lang sila. So from that, so M1 V1 plus M2 V2 is equal to M1 plus M2 is times V prime. So no need to put V1 prime or V2 prime. Okay, same naman sila. So V prime lang siya. Rewriting that expression, you get this. Okay. This one. Kuha na siya kanina mark. So M1 plus V1, M1 V1 plus M2 V2 divided by M1 plus M2. So that is for inelastic collision. So here we have an example of a 2,000 kilogram car moving at 30 kilometer per hour. Strikes a 1,000 kilogram car and two lock bumpers. What is their final common velocity just after the collision? So, bangga siya pack. Tapos sila. And they go. And they move together at the same time. So, recall the non-elastic or inelastic collision expression. It's M1 V1 plus M2 V2 divided by M1 plus M2. So we substitute the values of 2,000 ang massa M1 and 1,000 sa massa M2. And of course, ang total mass is 3,000. It's a quite big number. So 2,000 times 30 and plus 0 here. Okay, 0 man siya at rest. Divided by 3,000. Divided by 3,000. So what is that? Let's double check. So it's 20 kilometer per hour. Okay, check. Next one is you have a 200-gram glider and a 600-gram glider are coupled together and move along a frictionless air track at 50 centimeter per second. An explosion charge on one of the gliders separates them, causing the 200 glider to stop. What is the subsequent velocity of the 600-gram glider? Okay, so nagtapot sila una, na explosion, nagbulag silang duha. To the point na ang 200-gram glider, after explosion, is stop siya. So, final velocity niya sa kaning 200-gram glider should be 0. Ang pangutana, what is the final velocity sa imuhang 600-gram glider? So, this is like this the scenario. So, initially, they're nagtapot, they have the same initial velocity. V1 is equal to V2, 50 centimeter per second. After collision, ang V1 nimo, V1 prime nimo 0, o ang V2 nimo just keeps going on. So, what do we do? So, we use, again, the expression for momentum. So, this expression here, M1 V1 plus M2 V2 is equal to M1 V1 prime plus M2 V2 prime. Note that same sila og initial na velocity V, so we can factor out V and sum the two masses. Okay, then at the second point, ang imuhang mass nimuha, ang imuhang V1 prime mo 0 na siya kay ni-stop man daw siya. So bilhin na lang is M2 V2. So V2 M2 V2 prime. So factoring out, not factoring out, but crossing this one here, you get this expression here, same M2. This one is obviously 0 because of this scenario here. So substituting the values, M1 plus M2, which is pila to siya? 600 plus 200 is 800 grams. Then times the initial velocity 50 centimeter per second divided by 600 grams. So the grams cancels out and you're left with a velocity unit, velocity na parameter. 800. Let me just double check. It's 66.7 centimeter per second. Okay, that's correct. Let's move on. So far, we discussed an example sa one dimension. How about two-dimension interaction? So here you have on an axis X, ni-move ang imong M1, ni-collide siya sa M2 that is initially at rest. Then pag collide niya, nagbulag sila in a two-dimensional axis. Okay, so V1 prime going theta 1 prime counterclockwise with respect to the positive X, and V2 prime nimo is moving in the theta 2 prime measured from the positive x-axis, but it is clockwise. So, nasa sa fourth quadrant. So, let's look at the sum of forces, or no, the sum of the quantities along the x and y axis. Okay, duha man siya. So, in the x direction, you have this one, M1 V1x plus M2 V2x is equal to M1 V1x plus M2 V2x. So, these are the initial condition. So, ang imuhang, maybe we should look at first the figure here. So, clearly this one is M1 V1x o M2 V2x. Pagbulag niya, nasa duha ka component. For example, sa V1 nimo na siya V1 prime x. Ang imuhang M2 na siya V2 prime x. Similar na po siya y component V1 y prime o ang imuhang the other parameter is V2y prime. Okay? So, duha siya ka axis man. So, we look at again. So, you have M1 V1x plus M2 V2x. So this is 0 kay ang imong mass 2 is initially at rest. Then, diri na po dayon, ang mga components di is just along the x-axis. So v1 x prime plus v2 x prime. So cosine theta prime atong ginagamit. So if we go back, so let's look at here. So you have ang imuhang theta here. So let's say if this is v1 prime x, so that is clearly a cosine theta 1 prime, which is equal to the adjacent v1 prime x over the hypotenuse v1 prime. Okay, you do the same here. Do the same here for theta 2. So cosine theta 2 prime is equal to the adjacent. Adjacent niya is ang v2 x prime. So v2 x prime over v2. Okay. So hence mo ni siya cosine. Oh, yeah. Let's take this one further. Simplify this one further, I mean. So here, sa imong v1 prime x is equal to v1 prime cosine theta 1 prime o kani siya. This is v2 x prime is equal to v2 prime, v2 prime cosine theta 2 prime. So mo na nahitabo diri class. So ang imong v1x is this function v1 prime cosine theta 1 ug ang imong v2x prime is this one, v2 prime cosine theta prime 2. In the y direction, you have again this one sa y direction. Initially, nag-start man sila motion lang along the x-axis. So 0 ni siya. Kani po siya at rest, 0 po na siya. Now, ang nahitabo is that na siya y components at after the collision. So m1 v1 prime y o m2 v2 prime y. So what do we do is, of course, let's determine ang v1 prime y o v2 prime y. So here, let me erase again. So kani siya may imuhang v2 this is v1 prime 1. So that is a cosine function, so we're clearly gonna use sine theta. Sine theta 1 prime is equal to the opposite, which is ang imong v1 y prime. So if we conduct it here, is equal to the hypotenuse v1 prime. So rearranging, ang imong v1 prime y is just v1 prime sine theta 1 prime. Also here, this is v2 prime y. So sine theta 2 prime is equal to v2 prime y over the hypotenuse v2. Rewriting that function here, v2 y prime is equal to v2 prime sine theta 2 prime. So pag abot ni mo nga ni, this becomes ang v1 prime y, this becomes v1 prime sine theta 1. Okay, mong v2y, it becomes like this. Okay. Oh, medyo kotigid siya sa class. Conservation sa momentum. Momentum ni mo na calculation. Okay, depende sa number of axis. Ang kanais sa kuan sa energy calculation for the collision. So we just started with this one. So you have 1/2 mv1 to 1/2 m1 v1 squared plus 1/2 m2 v2 squared is equal to 1/2 m1 v1 2 prime squared plus 1/2 m2 v2 squared prime. So sa katunang scenario, ang imong v2 squared is ang v2 nimo is 0. So nawala siya. So the expression is given by this one's a conservation of energy. And as you know, you don't need components for this one, kay energy are scalar. Okay, Scalar siya na quantity. So we have the following expressions. Kani siya. Wait. Kani. Let me. Kani siya. Kani siya. O kani siya. Actually, you can even cancel out ang mga 1/2 here. So that is the expression na mathematically defined sa katong collision na mag-result in two-dimensional na plane. So, let's go. So, you have two ice skaters, si Daniel, 65 kilograms, Rebecca, 45 kilograms, are practicing. Daniel stops to tie his shoelace, and while at rest, is struck by Rebecca, who is moving at 13 meters per second. Before she collides with him, after the collision, Rebecca has a velocity or magnitude of 8 meters per second at an angle of 53.1 degrees. Okay? Banggaan sila from her initial direction. So, si Mang siya sa 53, so that means na siya sa first quadrant. Both skaters move on a frictionless horizontal surface of the rink. So, ice rink ni siya. So, letter A, what are the magnitude and direction of Daniel's velocity after collision? Magnitude and direction. And letter B, what is the change in the total kinetic energy of the skater as a result of the collision? Let's begin. So, first scenario is this one. So, nag-slide si Rebecca, nag-attract si Daniel. So after that one, nag-collide silang duha ug ni-move sila in two different directions. That's right. Si Rebecca is now in the first quadrant, 53.1 degrees, while si Daniel is unknown ang iyahang angle, unknown po ang iyahang magnitude. Okay, let's solve this. First, we do the momentum calculation. So we use this expression here itong kaganina. So we know na si Daniel was at rest, so this one is set to 0. So we are left with this expression here. So m1v1 is equal to m1v1 prime cosine theta 1 prime plus m2v2 prime cosine theta 2 prime. So substituting the values, this one is just 45 times 13, 45 kilograms times 13 meter per second, you get 585. And this one is 45 kilograms times 8 meter per second times cosine 53 degrees. Ang pagsimang niya, you are left with this one. Pantanggal din akong units na okay. And lastly is kanisya. So we have 65 kilograms, pero anon ang V2 prime o ang cosine theta 2 prime. This is in the x direction. Let's look at in the y direction. Sa y direction, ang imong m1vy ug m2v2y, they are both 0. So, 0 na silang tanan. So, ang mabili na lang is ang mga y parameters after the collision. So, you have m1v1y prime ug m2v2y prime. So, we know ang v's, ang mga vy prime are given as a sine function. So, you are given this one. So this one is gani siya ang resulta, 45 na mass times 8 meter per second, so right, times sine 53.1 degrees. And sa imong m2 is 65 kilograms times v2 prime na sine theta 2 prime. So unknown siya, so as is na siya. So we now have this equation A and equation B. So rewriting equation A, this is from the x-axis, to express it in terms of v2 prime. What we do, we transpose this and we divide it by 65 and cosine theta 2. So this one is simplified as 5.65 over cosine theta 2 prime. Similarly, ang same equation B, we do the same. So we transpose, or ining transpose kay negative na dam, mas convenient. We transpose na to siya, essentially creating this same expression. Then we divide it by 65 Oh no, sine theta 2 ang expression kung ito. Ano ba? Okay, we can do that. So, wala siya divide by that one, but rather, ang sine theta 2 na expression is just divided by this one, you get 4.43 divided by v2 prime. So you get an expression for v2 prime of sine theta 2. Okay, obviously you need to solve expression. So we have again another a prime expression for the v2 prime, v prime for the sine theta 2 prime. So what you do, of course, substitute natin siya. So sine theta 2, so you substitute here. So that becomes mabaliktad siya, cosine theta 2 over 56 rather than not 56, 5.6. Then 4.43. Then from here, ini siya baliktad, it becomes 0.78 cosine theta 2 prime. Okay? What do we do? So we now have sine theta 2 prime function. So if we what do we do? If we equate nato, of course equate naman diba? If ibutaw nato ni siya, right? Yeah. So if cross nato ni siya dire, gives you a function na sine theta 2 from here, sine theta 2 prime, of from this one, nag-drop ni mo dire cosine theta 2 prime, which we know is equal to a tangent theta 2 prime. Tangent theta 2 prime equals to 0.78. So ang theta 2 prime, ipagawas ni mo ang tangent inverse of this one, 0.78, gives you the value of theta 2 prime of around 38 degrees. Wow. So that's the direction theta 2 prime. So hain siya gi-measure with respect to the positive x-axis, and it is clockwise. Let's see. Figure. Yeah, clockwise. Clockwise, yeah. Panahon siya. The next one is ang yung magnitude. So we choose equation A prime. So V2 prime is equal to 5.67 divided by cosine theta 2 prime man siya, which we know is 38 degrees. So substituting that one gives you 7.2 meter per second na magnitude. So okay. So we now have the magnitude and direction. That's for letter A. Next is ang energy calculation. The energy calculation, ang energy here is just kuan lang siya. Kinetic energy. Na isa at rest pero it's on the surface. So hindi siya potential energy due to gravity. Just kinetic energy. So the change in kinetic energy is the energy final or primes minus the initials. Okay? So kinetic energy nimo sa initials are kanisya mga velocities atong bantayan. Na, however, we know that ang imuhang initial na velocity is just coming from mass 1 kay imong mass 2 is at rest. So this one is 0. And we can factor out the mga 1/2. Okay, so you have 1/2 here. And we can substitute the values given and obtained earlier. So, this appears to give a negative na total kinetic energy. Negative 677.7 joules. So, we now have the final velocity of mass 2 and its direction and the change in kinetic energy. Next one is ang center of mass. Center of mass is used to simplify interaction of forces for a given object. So as you can see, kung bola lang, perfectly symmetric, wala na yung problema. It just simply moves in that trajectory and you can even assume na mura siya wala nagliyok. However, if we're talking about irregular shapes like this one, like ang kaning bat, pag tira ni mo, it seems to be rotating around its about its axis. So what is this axis? So if you have duha ka masses separated, ang center of mass nila is given by this expression. Basically, asa siya balance. So it's just m1x mass 1 times x1 position siya o mass 2 and ang yang x2 na position. So m1x plus m2x2 is equal to the sum of the total masses. So you get this expression to determine the center of mass. Okay. However, if you have multiple particles like this one, mn siya, meaning like daghanig kayo. Ang center of mass along, let's say for this axis along x, is just simply, again, an expanded version sa itong kaganina. So, kani siya total mass. Kani siya is the masses with respect to some distances. Okay, distances. And you can determine the center of mass along this axis. Next one is kani siya. If you have a body na containing multiple masses and you want to determine ang iyang center of mass. For this case, it's in 2 dimensions. So we have to use double dimension ang xm o ang xcm o ang ycm. So it's just simply the same lang. m1x sum ni mo na tanan divided by the total mass. Here sa y po na axis, sum ni mo tanan mass multiplied to that y position divided by the total mass. Then you have the coordinate of in 2 dimension ang iyang center of mass as xm o ycm. Here pag 3 dimension, so kanila gyapon buhaton. So kaganina is just xm o ycm. Now kung may ka third dimension, dunga ganun na to zcm. So xyz na siya na coordinate. So in vector form niya, ang imuhang RCM vector is just the sum of mi ri, which gives you the vector part divided by the total mass. So ri is the position sa ri indicates position siya by the ith na particle. For example, this one, this is r1, this is r2, this is r3, so this is ri. So daghan na kayo. So that means I equal to 1 to ith particle, basically, and you'll get the vector form niya. So here are the 4 different types of dili symmetric na mga bodies. As you can see, kaning red na cross indicates the center of mass niya. Depende sa distribution sa masses sa isa ka object. Okay? Oh, here we go. So find the center of mass of a system consisting of 3 particles. M1 is 2 kilograms, M2 is 4 kilograms, and M3 is 6 kilograms. M1 is at the origin. Then ang M2 ni mo na siya sa 3 meters along the y-axis, and ang imuhang M3 is 4 meters sa imuhang x-axis. Let's go. So 2 dimensions, so we need an xcm or ycm. So we look at this function here. Mi xi is equal to m. Ang m ni moha will be the same. Total mass niya. Which is 12 kilograms. Total mass niya. So kanila na mag-vary. So you have your mass here. Okay, I have your mass here. So you have the first one, mass 1 of x1. Mass 1 is 2 kilograms na siya sa in respect sa x-axis, na siya sa origin. So that means 0 siya, na siya sa 0 position. The second mass, ang m2 na siya sa ang m2 nimo is na kay 4 kilograms, pero ang position niya is nagyapon sa origin, so 0. Ano siya, di ba? So that is 0 siya sa x-axis. Pero ang imuhang mass 3 na 6 kilograms na siya sa 4 meters. 4 meters siya sa x-axis. So 6 times 4 gives you 30. divided by, oh no, 6 times 4. Tingnan ako. I made a mistake. Sorry, it's 24 divided by 12. Why did I say 30? I'm getting, sorry class, I think I'm getting dumber. So it's 24 divided by 12. So it's 2 meters siya sa x cm. So somewhere siya dire. Let me clear this one. Okay. The next one is ang imong YCM. Sa YCM nimo ha, ang imuhang first mass M1 na siya sa Y1 which Y1 is na siya sa origin, so 0 gyapon. So this gives you 0. Okay? Ang imong M2 na siya sa origin pero na siya sa yung Y position na siya sa 3 meters. Okay, so di siya 0. Then ang imuhang mass 3 kaya siya na siya sa origin. So ang iyang Y na siya sa 0. Okay. So 4 times 3, 12 divided by 12 is equal to 1. So this is your location. 2 meter by 1 meter. So 2 siya, 1 siya. So mao ni siya. Mao ni siya imong ipulahan na ba na ako daan. Okay. So mao ni siya ang imong center of mass sa two-dimensional na line. Center of mass and translational motion. Like for example, this one, ang isa ka person ni ambak ni somersault siya. Na siya particular movement. So nag-rotate siya. So first agad nato mga motion is kuan lang. Kung maglabay ka, wala siya mga rotation. Okay? So maybe we're checking on this one. So you have as we mentioned earlier na kay mga forces, internal or external forces. From form of the center of mass in a two-dimensional with n particle system is given by this expression. So M total mass RCM is equal to the sum of the individual mass times the radial position of those individual masses. Let's say kung nakay partition dira, you have R1, R2, R3, and so on. So, MRCM is equal to this one is, if we can also transform it into a derivative form, it's drCM over dt. drCM over dt is equal to M dri over dt. So clearly, di na siya just a distance, it's now a motion, it's a velocity here. So m times the velocity cm, okay, is equal to the sum of the individual masses times the individual velocities. So where vi is equal to the rate of dr over dt is the velocity of the ith particle, and vcm is the velocity of the center of mass of the body. So if you have like this one, hamuki siya, particles in a body. So this is the position as cm, center of mass. It's like mo ni siya ang representation sa iyang velocity, vcm. Okay, vcm siya, the velocity of the center of mass. So we differentiate this equation with respect to time. So ang imong kanisya this expression, dividing mo by time or differentiate one, this becomes dvcm over dt. This becomes an acceleration na parameter. Okay, so where a is the rate of dvi over dt and it's the acceleration of the ith particle. So dvcm now over dt is the acceleration function. So dito siya nagbali na represent sa motion niya sa atong position. Okay, from Newton's second law, fi is equal to mi ai. So the force exerted on the ith particle is equal to MACM, mass, total mass times the acceleration of the center of mass of that body. Here, Fi, and F2 are the external and internal forces respectively. Since from previous discussion, we discovered that the net internal force is zero or cancels out. So, ang mabilin na gidaan na is ang external na force is equal to the total mass times the acceleration of the center of mass. Okay, the sum of all forces acting on the system is equal to the total mass of the system times the acceleration of its center of mass. So this statement is Newton's second law for the system of particles. Thus, we can conclude that the center of mass of a system of particles or bodies with a total mass m moves like a single particle of mass m acted upon by the same net external force. So, okay, ang isa magdasayo po na yung mga lahi ng mga shapes. So, to simplify that one, we focus on the center of mass, which is essentially reducing this image to like point lang siya na particle. So dira bali mo represent ang acceleration cm and others. Okay. This expression, we can also rewrite this in terms of the momentum. If you remember, momentum is just the mass times velocity. So you have momentum total is just m1 v1 plus m2 v2 and so on to the mn vn. So it's just the sum of the individual na mga momentums. And from the expression, the force external is equal to mass times acceleration of the center of mass, we can rewrite this one, this expression, force external, as P is equal to mvcm. Okay, P is equal to mvcm. Okay, and Newton's second law for the system of particles is equal to the change in momentum over dt is equal to the force external, because the internal gives you, they cancel out the internal. Okay. Whew. That's it. So I hope you learned something new today, and ingat and God bless.